Yeah, good morning, everybody. It's great to be back in Bangalore. I just came in. I had some supply chain questions to come here. And this question of supply chain seems to be a story which follows along for some days now. Are you aware of that we are closer to 2050 than we are to 1990? I got aware of that because I had birthday, and on my birthday we were, just rethinking the years, and so I got to know, yeah, we're closer to 2050 than we are to 1993. So isn't that amazing? 2050 we should be net zero. This is a challenge. This is a real challenge. So why do I talk about birthdays? My daughter, she was about to give me a cooking spoon as a present because I like to cook. She was not able to deliver that because of supply chain issues. So what did I get? I did get a algorithm for my digital bookshelf. This is 2050. Okay, back. So what are we about? Get my presentation started. It's not here. We try again. Technology. Here we go. We are about signals. So this 2050 is a signal. We are closer to 2050 than to 1992. We as EDG, Enterprise Development Group, would like to take you on a trip with the following questions. Where's the world going to? Whether we go there or not? Who do we want to be in that world? And how do we get there? These are the three questions. The first one is important for me because we always have to make a decision. Do we want to be there or not? But it's happening. So I would like to encourage you to rethink maybe your own business model, your own thinking. What role do you want to play in that? A good friend of ours, Kurt Carson, he's the guy who developed this ancient thing, human interface to the computer, mouse. Kurt Carson, he said, in exponential times, if you improve your performance incrementally, you fall back exponentially. So if you only go step by step, you fall down exponentially. And the good question is, do we live in exponential times? Yes, we do. That's what you see there is the NASA curve of CO2 emissions. And we are currently at 418 ppm, parts per million CO2 in the air. And you see the steep curve going up, it's exponential. And looking back into the times, when was the last time we had these sort of 400 ppm in the air? It was in the Pliocene. So the Royal Meteorological Institute asked themselves, what was it like to live in that surrounding of 400 ppm? Well, you look at it, the sea levels were 15 meters higher. 15 meters. The average temperature in the Arctic summer was 14 degrees higher. That's what we're facing. Even though we try to achieve the Paris Agreement. You might ask yourself, so why is it so different now? because it took 1 million years to get there, not 150. Just a few slides on that. On the Arctic Circle, in the year 2020, we had 38 degrees on the polar crust on the Arctic Circle, where it should be very cold. 1 year later, in 21, we had 39 degrees there. You know the permafrost, the methane there, all goes up. Let's go to the other side of the planet. Should it work? If we go to the Antarctic this year, we had 70 degrees more Fahrenheit than average. 70, that's around 21 degrees. 21 more temperature, higher temperature on the Arctic Circle. And we had 25% less ice coverage. 25% less ice coverage. Let's check out what happened in Portugal. It was the driest summer for 1,000 years. How do they know that? Because they go into the caves and look at the limestones, how they developed. And they can see very clearly it was the driest for 1,000 years. Over 1,200 people died of heat. Talking about India. On the 15th of May, you had 45 degrees in Delhi. Well, sometimes it gets hot, I know. But if you look at the Weather Climate Attribution Institute, it says the possibility that it gets so hot again, it's 30 times higher than it was in pre-industrial times. 30 times higher. So it's not a one-off thing. On the other side, what we see is with each temperature, each degree Celsius we add to the atmosphere, we get 77% more moisture into the air. 1 degree more, 7% more moisture. So what happens with this moisture? Well, it comes down. And it comes down at places where you don't want to have it, like in Greenland. It was raining last year on Greenland on the ice. And on one single day in August, the ice melted there. The amount of ice which melted there would have been able to cover the whole state of Florida with 5 centimeters of water on one single day. Do we live in exponential times? Yes, we do. That's what you see at the moment, floods. Here in Bangalore. And Antonio Guterres says that humanity faces collective suicide caused by climate change. And I think this is a signal. And if Mark Carney, the governor of the Bank of England, says firms ignoring climate change will go bankrupt, this is a signal. And if Swiss Re, not known for being a very green company, says we are facing 18% GDP loss through climate change. 18%. Do you know what the Lehman Brothers story was? How much did we leave there? How much did we lose? 3. 18. What else do we see? We see the urbanization, of course. People are moving into the cities. And here's something which really should make us think. In the next years, and the next 40 years, every month we will build a whole New York City new. Because the people are moving to mega cities, and they need a place to live. So every month, for the next 40 years, we will build a New York City. And this is what we will see. 68% of the world population will live in megacities. 68%. And cities like Delhi will grow up for 48 million people. That's adding from now on another Belgium. Just putting the whole of Belgium into Delhi on top. That's what you see. Another interesting signal is when we look at where the megacities are, they are within the reach of 2 meters sea level height. 410 million people living in these areas, in these megacities. And when you think about the sea level rise, 2 meters, that's done. They're toast. You've heard about Jakarta, Indonesia? They moved their capital to Borneo, 800 kilometers away, up the hill. And if you have 410 million people in danger because of 2 meter sea level rise, think about the infrastructure behind that. Sewage, fresh water. It's not about 2 meters. It's about 10, 15, 20 kilometers inside the land. And there's a business case behind that. The World Bank says, if you look into the future, we've got 29 billion investments coming up due to climate change projects. In the fields of green buildings, public transport, electric vehicles, improved management of water resources, renewable energy, better handling of waste. And I think these are all the topics we're going to cover on this conference. So switch the perspective. Yes, there's a danger, but at the same time there's a chance, there's a business case. And this business case is big. So what do we have to do? We have to draw down. We have to draw down that curve, the CO2 emissions. So what we see is, it's like a tub, a bathtub. It's running full. So what do? First, turn off the tap. That helps. Second thing is, pull out the plug. And third thing is, doing something crazy, but that's at the end. So, turn off the tap and stop adding CO2. This is a business case. Where does it come from? Electricity production, and this will be the next panel. 25% of the CO2 or greenhouse gases are added by electricity production. We better rethink what we do there. And there's one project from Stanford University. They're using 3D printed solar panels, like pyramids. They turn it upside down. And the effect is they gather 90% of all the light which is gathered, which is coming from the infrared. 90%. Normal solar panels are around 30%. It's 90%. And the energy which is collected there is 90% higher. It's just a new study, came out this June. Check that out. Smart street lighting, of course, turn off the tap. Like the mayor of Chicago says, if we use smart lighting, and they do, they're going to save $10 million per year. And the mayor of London says, if we apply really smart lighting, the whole thing, we're going to save up to 70% of electricity waste. 70%. So let's do it. Second thing is agriculture. 24% are coming from agriculture sector and land use. So we have to rethink that place. And when you think about urbanization, New York City, megacities, well, let's check that. An MIT startup, Growtain, for example, checks what the population is in the megacity, what kind of food they need, calculate that, and give that straight over for urban farms. Like in Singapore. Singapore wants to produce 30% of their food in Singapore. And you know, Singapore is a city. So this is the new farmland. Smart logistics will be a core on that. Through food waste, we add another 6% of CO2 emissions. So we better check where our food supply chain goes. So there's no interruption on the whole supply chain. And it's very easily done now with smart sensors. UNC is one example for that. Industry, 21%. This is, for example, BMW. They have to rethink the whole thing. Rethink, reduce, and recycle. And this car you see there is the circuit car. And I put it there because maybe there are some OEM suppliers here. If you have mixed materials, you're done. You're toast. Because you have to separate them again, to recycle them. And it's not just a fancy game, it's a business game. You see, you probably can't see it, well, see it very clearly. It's the Container X network. What happens there? All the OEMs and the OEM suppliers are coming together on one platform and sharing the CO2 footprint right from the beginning of the product to the end and back into the circle. And the guys which are behind that are SAP, for example. Who should know a product better than SAP? They track the whole CO2 footprint along the whole way. And if you're not doing it, you're out. Transportation, another 14%. Well, let's check out that one. That's Autobahn. Autobahn is a startup from Munich. They just implemented the first railway. They can build up this infrastructure very easily. It's 30% of a normal tram. And I just saw yesterday that Bangalore is talking about having them under the highways. So yeah, this is one solution, getting the public transport efficient. Another one is Aptera. And I was just asked, do I think EVs are the future? Yes, I think they are part of the future. You see here the car Aptera. The Aptera has got solar panels on the car. And it got a range of 1,000 miles. Just by solar panels. The other one is the Sonomotor, German startup. And actually, I put this slide up because it's again running on solar cells. The car fleet operator Finn purchased the whole year's production. And Finn is one of the biggest fleet operators in the world. So there's a signal. Building on-site, you add another 6%. And I took this picture here because I think it's an interesting one when you think about cities. That's Seoul. Seoul got a map, a digital twin of the city, available for the citizens. So you can plan your building there. And what you see there, here's the wind draft, for example. The wind draft, what it is in Seoul. So you can adjust the angle of the building so you have a cooling. And it's open for everybody. It's not owned by anyone, this data. It's open for the citizens, for the businesses. And 10% is coming from others. So what do we have? We have got one side adding CO2, and luckily we've got on the other side a sink. So we've got the natural sink of CO2. And this is 24% by land and 17% by the sea. But the bad news is 59% stay in the atmosphere. And we add that year by year by year. And this legacy is going to challenge us. So we better think of pulling out the plug. So getting the sink better. So there are different ways to do that. One obvious answer is planting trees. Yes, it's always good to plant trees. But the problem is, for the CO2 footprint of an average American, you would need 660 trees. And the bad news at the same time is we have a strong reduction of trees at the moment around the world. And all this certificate trading thing about planting smart trees, you better rethink that. So maybe there might be some technology around, like CO2 direct air capturing by Climeworks, ETH startup from Switzerland. What they do is, it's like a big vacuum cleaner, sucking in the CO2 and pressing it into the earth. The bad news about that one is what you see here is the city of Nuremberg. And if you would use the whole CO2 from the city of Nuremberg, you would need 96,000 vacuum cleaners. So, here's an interesting one. Remember, each month, 40 years, one New York City. This company called Blue Planet is capturing CO2 out of the air and is developing out of that concrete, artificial limestone. What better way to capture CO2 for a long time in a building? There's another one, and this is even better. It's about the blue energy, capturing CO2 direct out of the sea. And what you see there, these white cliffs, these white cliffs are the white cliffs of Dover. The nature does it. They captured already CO2 in limestone. And the University of California developed a procedure to develop out of the water, to draw CO2 out of the water and put it directly into artificial limestone. Now, a few crazy things, and I'm in the end, Jos. So we've got the question of turn off the tap, pull out the plug. Now, maybe we have to do something crazy in between because the temperatures are rising dramatically. Pliocene. How about helping to reflect the infrared radiation? And one way to do is to have white clouds. What you see there is a picture from the Arctic Sea, the Bering Strait. At the Bering Strait, at the moment, container ships are driving around there. They exhaust fumes, and these fumes develop into clouds, and these clouds are getting white. And this white reflects the sun rays much better than dark. So maybe we have to do something, which I'm sort of hesitant, but I know we have to immediately work on that, do some geoengineering on that. And it's already done. The University of Sydney deployed these boats, whitening the clouds above the coral reef, the Barrier Reef, Great Barrier Reef, and the bleaching was reduced tremendously. Now, we can say now, okay, yeah, geoengineering, are we really able to do that? Should we do that? Well, we do it already. This is Switzerland, for example, and the whole Alps. At the moment, 67% of the Alps are covered by artificial snow. We do geoengineering already. And we do it in a bad way as well. Every day, we are blasting out fumes, changing the climate. So let's think curiously and precisely about what can we do with our engineering heads to change that. In exponential times, if you improve your performance incrementally, you fall back exponentially. You're not lost, you're here. What we need is, we need your ideas, and that's what we do together as EDG, Enterprise Development Group. We look at the signals, start together with the company to develop a blueprint, what the strategy might look like, implement innovation architecture, and then pivot or scale. That's what we do. And we do that in Palo Alto. We do that in Switzerland. We do that in Slovenia. We do that in India. And maybe you might like to think, what is my existing business today? What happens with climate change with my business? What will I stop doing immediately? What do I learn from my incremental business? and what do we learn for our new disruptive business? Thank you very much.
Thank you, Jan Kuenne, for that wonderful presentation.